we want to find the volume enclosed by these lines. So our job is to draw and see the region, how it looks like first. So, oh, this is 3x squared. 3x squared plus 12. In order to graph it quick, remember, x squared is this guy, right? X squared is like this one. Therefore, 3x squared, it will be shifted vertically. It will be like this guy, okay? But then it is shifted 12 units up versus plus 12. Therefore, the graph should be somehow like this. Okay, 12. Let me draw it a little up here. Okay. What is the minimum value of this guy? So, yes, 12. Okay, or the y-intercept here is the minimum value, which is 12. Okay. So now let us draw the graph here, 4x plus 3. What is the y-intercept? This guy? Y-intercept is where x is 3, right? Okay, very good. So this point belongs to the second graph here. And okay, before doing that, I think it's better to write x is equal to -2 first. Okay, remember, at each axis, we should define the unit equally. So it means that if here the one unit is like this, but the two scale in x and y does not have to be the same, okay? Here the distance from 0 to 3 is 3 units here, but in the y direction we can divide it differently, it's fine. So now here the axis is -2, it should be this guy, right? And here at x is equal to 3 is this line. Okay? Now at x is equal to 3, what is the value of this curve? $15, yes, very good. 15. So 15 should be somewhere here. So at 3 it is 15. Then we connect the line here. Okay. Then we know that this line is 4x plus 3. Now from the given information, we know that the region bounded by these lines would be this area. Okay? If we call this function is the function f, and this is the function g, then we know that f is always larger than g, right? According to the graph here. strictly larger. Okay? Or you can check it by making a table. Okay? If you define the function h of x is fx minus gx, which is here 3x squared plus 12 minus 4x plus 3, it becomes 3x squared minus 4x plus 9. And the discriminant of this guy will be negative 4 squared minus 4 times 3 times 9 smaller than 0. Therefore, this function has no solution. If it has no solution, then the table studying the sign of the function h of x here there's no solution. Then the sign of the function h of x is always the same size with the parameter of x squared, which is it is always positive. Okay, h is always positive, or we say that f of x minus g of x is always positive, or f of x is always larger than g of x. Okay, the study here agree with what we see on the graph here. But in the test, if you draw the graph here, then you're good. You don't have to do this table. Okay? I just want to explain and help you understand more. Then from definition, we know that the area of this guy the area, let us call it S. It will be the integral from the lower limit to the upper limit, right? In the variable x here, which is, what is it? -2 to 3, right? And it is enclosed by the two functions f and g. So we need to take integral of the absolute function of the difference fx minus gx. Okay? That is the formula. Then we see that f is always larger than g, therefore we can get rid of the absolute sign here. It means that this guy becomes integral from -3 to fx minus gx. And from the previous computation, it is this function, right? 3x squared minus 4x plus 9. Oh, interesting. Sorry, there's technical issue here. I cannot delete it. Okay, now it simply becomes negative, integral from -2 to 3 of 3x squared minus 4x plus 9 dx. Then it is an easy one. You can do it, okay? Okay. let me, yeah. Okay, yeah, and let us continue. Sorry, this works now. So, what is the antiderivative? Okay, now the constant here, okay, does not affect the integral. So it means that we can write it down here, and we take the antiderivative of x squared, right? Antiderivative is the reverse weight of the derivative. So we will take x squared here, then we add 1 to the power here. It is the inverse, the reverse way. So we need to multiply with a fraction whose denominator is the same as the power here, so that when we take derivative, they cancel each other. Okay. Here, Carrington, can you help me with the next one? Perfect, x squared. Or let me write it as 1 plus 1 here. And the same story, we need to divide it by 1 plus 1 here. Very good. And the number here, you can imagine this way. The number 9 here is 9 times x 0. Because anything to the 0 will be 1, right? Now the same trick, x to the 0, we add 1, it becomes 1, x to the 1. Okay? So, or now you take the derivative of 9x, give us 9. Makes sense. So doing integral, it's easy to check your work. Let's take the derivative. If it does not give you the integrand, then there's a mistake. Otherwise, you're good. Okay? But then we need to evaluate this function. We have the limit. This is a definite integral. So we need to evaluate it from x is -2 to x is equal to 3. Okay. So we evaluate this function with the upper limit first. But before doing this, let us simplify it. 3 divided by 3 gives us 1. This becomes x cubed. Minus 4 divided by 2 gives us 2. X squared plus 9x. Okay, this is the simplified one. Okay, let us evaluate this one. The first one, will be, we replace x by 3. Okay, it will be 3 to the 3 minus 2 times 3 squared minus 9 times 3. That is the upper limit. Then remember, subtract. There's a negative sign here, be careful. Subtract the evaluation of the lower limit, which is -2 to the 3, be careful, okay? Minus 2, -2 squared plus 9 times -2. You should be very careful with the negative here. Okay, now let us simplify it. This is 3 cubed will be 27, minus here 9 times 2, 18. Plus here 27 again, right? Subtract here, -2 raised to the 3 give us -8. Okay. Minus here, -2 Here is a 4. So minus 8. Here is minus 18. Okay, simplify it. So negative 18, and here is positive 18. So this guy will cancel this guy. So, and here, this is 2 times 27 minus the negative give us positive 2 times 8, which is 2 times 35. Okay, 70. Double check it if there's any mistake here. I do. Is it clear? So very good. I will